Please keep the applause going from Parity Labs for Torsten.
Thank you. Hi, everyone. It's absolutely great to have you here. It's a pleasure to be back at Sub0, and welcome to this presentation. As you know, Polkadot over time grew into a powerful and modular system. The downside of this is, though, that a lot of functionality is distributed across chains. For example, you have smart contract engines, but they only exist on Parity chains. You have governance, staking, and other systems on different Parity chains and system chains. And that means that application development is sometimes more complicated than necessary. For example, even simple workflows require to go across different chains and require asynchronous communication between those chains. The Polkadot Hub is going to change that and simplify things massively. So hello again, my name is Torsten. I lead the contracts team at Parity, and today I'm going to talk about how the Polkadot Hub and the smart contract engine that is part of the Polkadot Hub will redefine how to deploy applications on Polkadot. Let me talk about the past situations again. So as you know, smart contracts can only be deployed on Parity chains, and other logic is either on the relay chain or system chains. When I talk about other logic, I mean the native token, I talk about staking, governance, and similar systems. And that requires, for everything you want to do that spans these different systems, you need to use XCM and asynchronous message passing to combine these components. The consequence of that is that if you want to deploy an app, it is unclear where to actually deploy it. There is not one central place that is obvious to you. It requires asynchronous operation flows and also fragmented tooling because Parity chains have different systems and UX also feels very different. This is going to change. There is a paradigm change happening, and the label for that is the Polkadot Hub. The Polkadot Hub is the new central main place in the Polkadot universe for applications. And it is one system that combines all the things that I said before in one connected environment. So assets, the native token, but also other assets like stablecoins, staking, governance, and contracts all live in one environment, and that's the Polkadot Hub. And with the Polkadot Hub, also the boundaries are lifted that you had before, and that also means that this is the new way to deploy applications on Polkadot. Now that I talked about the Polkadot Hub, I want to talk about the component that I personally am most interested in, and that's the smart contract execution engine that is part of the Polkadot Hub. That engine is called Revive. And what's most important about Revive is that Revive has two different execution engines for two different kind of smart contract systems. On the one hand, you have the familiar EVM execution engine that you can use to run EVM smart contracts that you usually know when you use Solidity. But on the other hand, you also have a more modern engine, the PVM engine, and we support Solidity and Rust for PVM. What's special about these two engines is that they are not in separate ecosystems, but they are in one address space. That means that smart contracts for one system and smart contracts for the other system are fully interoperable. They can call each other, and they don't even know that the other smart contract that they call into, whether that's a PVM or an EVM smart contract. In addition to this, Revive gives direct access to runtime components that I talked about, staking, governance, assets, XCM, through precompiles. So all of this is directly connected in Revive. Let me just quickly talk about the architecture, about how you can actually deploy an application on Revive. Currently, you can use two different languages that you can start with, Solidity and Rust. If you use Solidity, you can just use the conventional Solidity compiler to compile Solidity code into EVM code, and you can run it on the EVM engine that comes with Revive. You can also use another compiler that's called Resolve C and also developed by Parity, That compiler takes Solidity code and compiles it into PVM code that you can also deploy. Again, EVM code and PVM code is interoperable. You can also start with Rust, then use just the Rust compiler and can deploy it as a PVM smart contract. Again, those smart contracts can interact with runtime components that are particularly interesting. I now want to highlight these two engines and what is special about them and why there are two different engines, because they have different advantages. Let me start with PVM, the innovative engine that unlocks a lot of computing power. So with PVM, you get more computing power than with conventional smart contract engines that you know from other smart contract universes, like with EVM. And you can also deploy larger contracts with more complex logic. And that opens the space for completely new applications. PVM is based on RISC-V, and as you might know, also in Ethereum, there is some movement towards RISC-V in the future, but Revive already uses RISC-V now and makes that technology possible to use for smart contract engineers. To get more technical, Revive actually has two different execution modes. One is interpretation. That's the one that we use nowadays. That's not yet the fast one. The full computational power becomes unlocked once we switch to the JIT compilation mode. That will only start next year. But in this mode, you get the full computational power, and I will give you some examples about what that makes possible. For example, you can execute heavy math in a smart contract. You can, for example, implement cryptographic primitives in a smart contract, something that's unthinkable with EVM. Unless you use some precompiles, but if you want to use a different cryptographic primitive, you cannot just deploy your own precompile. Getting more precompiles into a smart contract, into a blockchain, is a long process that requires consensus of all the other participants to deploy that in the new version. With PVM, you can basically deploy your own precompile. It's just a smart contract itself with all the computational power. Now, if we have PVM, why do we need EVM? Well, EVM has some other advantages, namely that you can just bring your EVM protocol that you might already run on some EVM chains. You can bring that to Revive today, and you can deploy it out of the box without any changes. You don't need to change the code. You don't need to change your tooling. You can just use the tooling that you're used to, the standard tooling, Foundry and Harded, for example, to deploy everything. And again, EVM contracts and PVM contracts are fully interoperable. If you have an existing protocol, by the way, why do I say this? If you have an existing protocol that runs on an EVM chain, you might not bring it to the PVM. You can only bring it to the EVM engine, because if you use an old Solidity version, it will not run on PVM. That's why the EVM engine is also important, to give you full EVM compatibility. There's one small difference, but crucial difference, that we have where our EVM engine is not exactly working like standard Ethereum, and that is gas handling, resource handling. Usually all EVM chains have exactly the same way they treat gas, but that doesn't work in our universe. Polkadot, at the bottom layer, uses completely different resource system to manage resources of a smart contract. In Polkadot, you have weights. They are two-dimensional. They are actually two different resources that you need to account for. And in this smart contract engine, we have a third resource, which is storage deposits. So there are three different resources to manage, but on the surface level, we only want to make one resource available or visible, because we want full compatibility with Ethereum tooling. That means if you have an Ethereum wallet, that Ethereum wallet will not understand the resources that you have in Substrate, and for that reason, we need to simulate gas, how you find it in Ethereum. And the system that we use internally is a mapping between the three resources and gas. This works in a deterministic way, but it's quite a complex system, and it still has a few differences, but they will not matter in practice if no one uses any hard-coded values, but just use proper gas estimation. So with this system, we still have full compatibility, and we also have DOS protection, which is the main reason for this resource management, so that works correctly. Now let me zoom out a little and talk about the Polkadot Hub again. on more general terms, this time not about Revive. I just want to mention one other big project, which is called Asset Hub Migration. It doesn't matter too much, but Asset Hub Migration, the technicalities don't matter too much, but the effect of Asset Hub Migration is that it set the stage for the Polkadot Hub. Asset Hub Migration achieved that one unified environment that allows you to have staking, balances, assets, and governance all in one environment, and this set the stage for Revive. Asset Hub Migration just got finished recently, I think just a few weeks ago, and now everything is prepared for Revive to come on the scene and come to full fruition. So this is actually the environment that was meant for Revive, the perfect ideal space for running your smart contracts and the Polkadot Hub. I now want to give 3 examples of what becomes possible with Revive and the Polkadot Hub. I mean, this is hopefully quite clear now that you can directly access governance, staking, and contracts, or from contracts, and you can also access native balances and other assets. All of that is possible now without any asynchronous communication. It can be done in one environment. Contracts, for example, can directly read the state of governance. It can react to systems, to any changes in governance, to new proposals, and whatever, so you can create your own logic to deal and interact with governance. For example, you can have triggers whenever something happens. And again, everything happens synchronously. Another example would be advanced workloads that become possible with PVM once the JIT compilation model becomes available next year. I talked about this already. Now with PVM you can do complex math, something that you couldn't do before because computational power of EVM is very limited. For example, if you have a DeFi protocol, let's say a lending protocol, there's usually a lot of complex mathematics that needs to happen inside the protocol. You need to reassess risk, you need to reassess positions, and you need to react to the market, any market changes. Since you cannot do all that complex logic on-chain, you need to move that off-chain, but it becomes not verifiable that way, it's not decentralized, it requires trust, and so on. With PVM, you can move it back to the chain, and you can do it fully decentralized and in a trustless way. Also, for these kind of protocols, you can do simulations in the protocol. If you want to do simulations to see what's happening, you can do this on the protocol. Simulations require a lot of computation, maybe if it runs in loops, also something that was not possible before. Cryptography, I already mentioned that. Something that you can implement directly in your smart contract now, because it's computationally heavy, but that's ideal for PVM. And when we talk about cryptography, one part of cryptography is particularly interesting, and that's zero-knowledge applications. There's so much happening in the field of zero-knowledge proofs, but none of that can actually happen in a smart contract so far because it's computationally very heavy. This unlocks new applications using PVM and smart contracts. And finally, I want to talk about the product strategy at Parity. You already heard that. We are going to build a lot of interesting products, and Revive and the Polkadot Hub will be the foundational layer of all of that. Of course, there are more foundational layers, but when it comes to the computational engine, that will run in Revive and the Polkadot Hub. So if you look at this, you have the hub. Inside the hub, you have the Revive. With EVM or PVM engine, you can choose whichever you want for your use case, for your product, and then you have these end-user products that run on top of that. Finally, I want to conclude with an outlook. If you're interested to build on Revive and the Polkadot Hub, you can start as follows. You can use EVM if you want to use your existing workflows and your existing system with the common tooling, Foundry and Hardhat, that you use out of the box. You can also decide to use PVM nowadays, and we provide similar tooling for PVM. You cannot use exactly the standard Foundry and Hardhat tooling because they don't understand PVM. They don't come with a compiler to PVM, for example, but we have our own variants of them that work basically exactly the same. And you can use precompiles to start to interact with the other components on the Polkadot Hub. When this is going to happen? Polkadot Hub, with all the components I talked about, will be deployed on Kusama in November, so we're very close. It will become available on Polkadot already in December. As I said, the stage is set for Revive to come to the stage, and other advanced systems will become available next year. I particularly want to highlight the JIT engine in PVM. And there's actually also more that we are discussing. So a lot of exploration happening about even other more advanced technologies that become available, for example, supporting completely new languages to deploy and develop your smart contracts. Don't want to go into details now, but stay tuned. If you're interested in working and deploying, you can scan this QR code. When you did that, I actually have another QR code to share with you. Where is it? Here. Parity is hiring. So if you're interested, where is it? Okay, there's a delay here. So you can, Parity is hiring. We build products. If you're interested to become part of that, please scan this QR code and be part of the future of Parity and Polkadot. Thanks a lot.
And thank you, Torsten. Do you want to see if folks have a question or two and take them, or are you ready to get to the part?
It's the end of the day anyway, so we're not in a rush, right?
We'd be glad to take it. And if you think of questions later, then I know Torsten and all the Parity folks will be happy to hear them, yeah?
Yeah.
Thank you so much for your time.
Thank you.
Give it up one more time for Torsten and really for Polkadot and Parity Labs building cool stuff.